Hello, I'm Kelly Hill, Executive Editor of RCR Wireless News, and I'm excited to have this conversation today about the era of agentic AI with Anil Kollipara. He's from Spirent Communications. He's their VP of Product Management in the Automated Test and Assurance Unit there at Spirent, and we are going to be hearing from him today. So please don't forget to submit your questions into the user interface as we go along. And Anil, why don't you go ahead?
All right. Thanks, Kelly. Let's go ahead. Well, the agenda for today is to talk about what are the innovations that are happening in AI, and especially how they apply to my favorite industry, which is telecommunications. And I'd like to go and give an overview and talk about a few specific use cases, especially around agentic AI and how those are helping shape the next generation of networks. Let's go forward. So there's lots happening with AI, and this is one of the most exciting topics. So how does AI apply to telecommunications networks in terms of opportunities it creates for our customers? So at a broad level, there are two areas. There's an internal use case and there's an external use case. Okay, let's talk about those. So let's talk about the external use case. So given service providers have decades of experience building finite, reliable networks, and they have all these data centers and all these power sources in these data centers, they become prime, providers of network as network as a service, infrastructure as a service, AI as a service kinds of opportunities. And then you will see that there's a lot of investment happening across the globe in terms of the service providers investing in building AI networks with the goal of offering these kinds of services to their end customers. And these end customers could be enterprises, this could be governments, especially, sovereign AI is very big, especially in Western Europe, for example, where data security and privacy laws are very stringent. And the service providers can offer a sovereign AI as a service kind of opportunities and use cases to enterprises and governments. So there's a lot of activity that is happening, and this is generating or supposed to generate a significant amount of revenue opportunities for our service providers. And if you look at on the internal use case side of things, there's a lot of network operations, obviously for service providers, network operations, and the network is the most important and the biggest investment and biggest part of their IP, if you will. And there's a lot of innovation happening in that space in terms of making those networks efficient, making those networks reliable, and steer or react more quickly to the demands of the customers or the end subscribers. And of course, there is non-network related use cases like customer service or billing and things like that. Okay. And together, these opportunities present close to $30 billion of opportunities for our service providers. So it's very exciting time for the CSPs. So if you focus today on the internal network use cases, I want to break this down into three areas of AI. AI or traditional AI has been existing for some time, and we've been already using AI use cases for predictive analytics and predictive use cases. This is like traffic prediction or root cause analysis. And the majority of the AI that was used here was more like machine learning and other traditional AI use cases. What's new with the introduction of all these large language models and some of the innovation coming from OpenAI over the last 3 and 4 years is this generative AI. And generative AI, by definition, means it is generating some content. So this has presented new set of use cases for our customers to use that capability to generate some content in the form of generating some scripts or topologies, or test cases in the networks, so that they can leverage or reduce the time it takes for somebody to create these kinds of things manually. And generative AI also allows this ability to interface and have communication in natural language. And this allows the users to be able to further have conversations with the LLM, and if they want to refine the test or they want to refine the use case, they can continue to do so. So there's a lot of activity happening around this in the form of Gen AI and assistants, agents, you name it. And this is where the early adoption is occurring in the industry. And the next evolution to generative AI is this agentic AI. And the key difference between with agentic AI is that it is it is kind of executing a workflow, a full workflow, or a part of a workflow that today requires a human to execute. Okay, and think about something fails in the network, and you want to collect all the related KPIs, PCAPs and logs. And then today you would probably do some kind of analysis on that, and then you come up with some kind of a potential cause for this. And then you would take all of that information, you call somebody, and then you will send that information to the person, and then maybe create a Jira ticket and things like that. There are many manual steps today, and with agentic AI, the goal is that you can completely automate this, where the AI itself is executing that workflow on your behalf. Okay, so that's
Anil, can I just jump in for a second? So I just have a question here, because I think this is a really useful image of, or sort of that captures some of the differences here. And I just wanted to ask, so AI has obviously been a part of telecom and network analysis for some time. We've moved to assistance, and then you're talking about agentic. So it sounds like the difference between AI as an assistant versus AI as an agent is basically the level of autonomy and sort of its ability to learn for itself, as opposed to being human prompted. Am I getting that distinction correct?
Yeah, it's very similar, or a bit nuanced to that is that the AI is being trained to execute a workflow. Think about it, right? With 5G, and the technologies that are evolving, networks are getting complex, and customers are implementing automation pipelines and automation workflows. So when they scale these operations, and think about when issues happen, it would be very difficult to have manual interventions to get to the bottom of it. You could do that, but it's going to be extremely time-taking, and it would be very cost prohibitive to scale that kind of an operation. With agentic AI and agentic workflows, the goal is that you identify a part of that workflow that was being done manually today, but you use the agentic AI to complete that on your behalf, with the goal of shortening the time it takes to complete that manual task from days to almost minutes. And that's the key difference with the agentic AI.
Thanks.
Thank you. Okay, so let's talk about some of the agentic AI use cases as they apply to the networks and infrastructure use cases. There's a lot of use of agentic AI in terms of designing the network, for example, traffic prediction, capacity planning, etc. There's a lot of use cases in operations and management, in security. There's also agentic AI workflows built into the network itself, right? For example, you have these agentic workflows built into network functions, and, for example, like RIC or in NWDAF, right? Or within the base station itself, so that it can make smarter decisions, to steer traffic based on traffic conditions, load balancing, and things like that. It's basically executing a workflow that prior could have been done through a human or a human intervention in the whole loop. So there are some of the use cases. But today we're going to talk about specifically around operations management, and this is around fault prediction, anomaly detection, and root cause analysis. This is a hot area right now, and let's get into the details of why that is a very relevant and a very important use case for many of our customers. So, with the evolution of the networks from all the way from 3G, 4G to 5G now, the networks are getting complex. It's not that you're just executing, you're not just running 5G as a network. You have to still maintain your 4G and legacy networks. On top of that, you have new complex technologies like cloud native and security and things like that. So there are a lot of technologies that are creating this complexity. These things are moving at a much faster rate. There's a complex supply chain behind them. So that's creating some complexities. And then the fact that the skill set shortages, right? Having a human or a network operations specialist who is a specialist and an expert in 5G, 4G, security, cloud, it's a myth, right? So you probably need to have many experts on the call to solve the same problem. So this is creating what we call as cognitive overload on our customers. That means for them to be able to manage the scale with this manual approach today, it's becoming unscalable. And this is an area where agentic AI can be really, really helpful. Again, with the goal of taking all the tedious tasks of going through the domain knowledge, through the logs, the KPIs, and getting to the bottom of the issue much more quickly so that the human can focus more on much more high value tasks than all these time-taking tasks. And when we asked our customers, we did a poll and survey with our customers, they highlighted that root cause analysis is one of the top use cases that they feel that agentic AI can be very helpful for them. So, if you look at it, our customers, right? This is a kind of a representation of the customer's journey from lab to live. Whether it's a new technology like cloud native or 5G, they have to start the journey in the lab, go to pre-production and to the live network, and the loop continues. Today, customers have a lot of capabilities or tools or skill sets in the space of managing the networks, testing the networks, and automating the networks. But if you look at the next part of their journey, which is if something breaks, right, how do you understand what is the root cause, what contributed to that failure, getting to the root cause, and a remediation plan? There's a lot of pain point. And because this is an area that is increasingly becoming tedious and complex because of the evolving nature of the networks. And there is a significant opportunity for us to help in that area and significantly improve the operational efficiencies. And that's where solutions like Luma, our agentic AI platform, come into the picture. So Luma has been trained on all the domains that you talk about, right? So an agentic AI that has the knowledge of your 5G protocols, of your the vendors, interactions over the 3GPP interfaces, the cloud native technologies. So it can first help answer any knowledge questions if the customer wants to build a test case or they want to understand specific part of the protocol from 3GPP. They have all that knowledge and interaction through conversations. It will help them execute their task, which is the task of building and automating these test cases. And then finally, when they run these test cases and then they run into some issues, getting to the root cause that we talked about is again, the agentic workflow can crunch through all that raw data and the logs across a multi-vendor network and get to the root cause as quickly as possible. It may not solve the exact the problem for you, but the fact that it is um, reducing the time that you would have taken to manually process that data, it's a significant win. And customers are loving that kind of the use case. So that's an area of significant value to our customers, and we are helping our customers achieve that value. So just to summarize, what are the benefits of using an agentic workflow in the area of root cause analysis and anomaly detection is to significantly reduce the mean time to resolution of executing these tedious workflows from days to minutes. And this can be done very holistically by collecting all these tedious and complex and vast volume of information across KPIs, logs, and PCAPs. And because it's a machine, it can run 24/7, and it can run much faster than a manual workflow. And in the end, getting to the root cause as quickly as possible so that you can fix the network and make sure your services are running as expected and delivering the kind of quality and reliability that your end customers would expect.
Okay. Awesome. Well, thank you so much, Anil. So my first question, as I was listening to the slides, um, was just sort of thinking about scale. And you talked about the difficulties and sort of the challenges that come along with scaling telecom networks. But then there's also a lot, I think, of interest in scaling AI, both externally and internally. So what does scaling AI look like in this context? I tend to think of scale as meaning, it's bigger, it's more, it's broadening and using these things across a wider range of potential applications. So is that the goal in this case, or is it something different?
Yeah, it's the goal. In the end, the scale I would think of scaling the business, scaling the operations, right? As customers, service providers are trying to get into this new age networks that can deliver incremental value, right, in terms of their offerings, being differentiated. There's a lot they have to do to scale their business. And a big part of that is making sure that your networks are providing the kind of SLAs and the kind of the services that your end customers would expect. And that scaling is very hard to achieve with manual human-based approach, especially because, again, we talked about the complexities, right? It is, you can throw humans at the problem, but that it's going to be cost prohibitive and unscalable. So for our customers to scale their business and their operations, they have to leverage the latest and greatest in the AI and the technologies, AI and automation and technologies. And that's what I mean by scaling and how AI can help scale the business.
It also struck me, and this was on the basis of one of your slides where you sort of walked through, all the different things between test and between lab to live, is that there's so many more little pieces now. As we get into more disaggregated networks and cloud-based and moving into more and more cloud native things, that it really kind of maybe makes sense that, if an AI can handle this little piece that maybe didn't exist before or was all integrated, then that's additional complexity that has been added to the system that maybe it actually makes sense for AI to do because it's such a discrete bit of the overall network.
Yeah, and all of these domains are very, very complex, right? I mean, cloud native, for example, let's take cloud native as an example. It's a beast on its own, and telecom companies and most network engineers, they have great understanding of the 3GPPs, but understanding the cloud native technologies at the level that is required is is a leap for them, right? So you can think of agentic AI. I mean, you can at the at the end of it, you want everything, right? You want all of these across all of these domains be solved by AI. But even if you solve one domain at a time, right, that presents a significant, a very scalable, very proportional value to their end customers. And but given AI, it's a machine. You can easily scale it to be an expert in each of these domains. And at some point, you would expect that AI is able to solve this multi-domain, multi-vendor, supply chain problems very quickly. But what I would say is that you don't have to start with that goal or with that outcome right away. That could be the vision or the end goal, but you can start taking action today with one step at a time, with one domain at a time.
All right. Wonderful. Well, thank you so much. We're out of time for this presentation. So thank you so much, Anil, for the insights and the expertise. And folks, please go ahead and join us for the next session.
Thank you. Thanks for having me.